Hello everybody, how are you? Today we will start with properties of logarithms. What about properties of logarithms? The first property we have here is logarithm base x of a over b equal to logarithm base x of a minus logarithm base x of b. That means we can change the difference here, difference 2 divided or the opposite. It's the same. We can change the divided to the difference. We will take it in exams also. The following thing we have logarithm base x a times b equal to logarithm base x of a plus logarithm base x of b. That means we can change multiplied or times to sum or the opposite. Now, this is the second property. The third property we have that log of a log base a of 1. So here we have the number 1 equal to 0 no matter what a equal to. So log base a of 1 equal to 0 no matter a equal to. No matter a equal to. The fourth property we have here log base a of a equal to 1. So if I have the base equal to the number, the results will be always number 1. Okay, the fifth property here we have log base a of x to the power n. We take it before in the previous lesson. We take it that if I have the number of the variable with an exponents, we can take the exponents before the logarithm or the opposite also right. If I have the number before the logarithm, I can take it as an exponents. So the last thing we have here in our notes that there is no log for negative numbers. There is no log negative numbers, only for positive numbers. That's mean if I have, for example, log base 3 of minus 1. That's not true. That's not right because I don't have a logarithm for negative numbers. So this is don't exist. Now we will take examples for these properties to understand it. The first example I have here log base a of 1. I said in the properties log any base 2 of 1 equal to 0. For another example, log base 5 of 1 also equal to 0. Log base half of 1 also equal to 0. So if I have here, I will write it in another color. If I have here of 1 number 1, that's absolutely equal to 0. So another examples about this property log base a of a equal to 1. So I will take examples. Log base 7 of 7 equal to 1. So here I have the base and the number are equal. So the results will always be 1. Another example, log base 5 of 5 also equal to 1. Another example, log half of half equal to 1. So if I have the same base and number, the results absolutely will be equal to 1. Another example for another property, I will take the property of log base a of x to the power n equal to n log base a to of x. So for an example, log 5 base 5 of 5 to the power 3 equal to, I will take 3 before log, so it will be 3 but multiplied by log base 5 of 5. I have another property said any log any base equal to the number that's equal to 1. I take it before here. It's the same. So here I will say that's mean equal to 3 times 1. That's mean equal to 3. So another example for this property, I have log base 2 of 16. So I can take the result of this log. I will make a trick. That's mean log base 2. I will transform 16 to powers, like 2 to the power 4. So that's mean equal to 4 log base 2 of 2. Also, I have a property said that log 2 of 2 equal to 1. So the result will be equal to 4 multiplied by 1 and equal to 4. Now I will give you as a homework an example. The homework said find log base 3 of 81. Find log base 3 of 81. Take this as a homework and send it to me. Now I will take another property that said, I write it also for you. The property said, this is very important property for logarithms, said log base a of x plus log base a of y equal to log base a of x times y. How can I take the benefit of this rule? I will take an example to see how can I take the benefit of this. And another properties that said log base a of x minus log base a of y equal to log base a x over y. So here we will take an example to see how benefit are these properties. I will take example set log base 2 of 17 over 5 minus log base 2 of 34 over 45 plus 2 log base 2 of 2 over 3. The example said prove that must equal to 1. Must equal to 1. How can I prove it? I will take the left hand side and solve it. It must equal to the right hand side and equal to 1. So I will take the left hand side and say, what can I do with the left hand side? The first thing I can do it that I take the benefit of the number here and take it as a power here. I will move it as a power. So here it will be log base 2 of 17 over 5 minus log base 2 of 34 over 45 plus log base 2 of 2 over 3 to the power 2. So this is the first step I do. The second step I will do, I will take the square of this number. So log 17 over 5 minus log base 2 of 34 over 45 plus log base 2 of 4 over 9. Why? Because it's squared. Now, I will take the benefit of these two properties, that I will transform the sum to multiplied and the difference to divided. How can I do it? I will show that to you. I take the same log and the same base. Now, I will take, as I said, I will take the same log and the same, it have to be the same base to this property. So, I will take log base 2 of, between the first number and the second number, what do I have? Between the first number and the second number, what do I have? Between the first number and the second number, there is what? There is minus. Between the second number and the third number, there is plus. So what I will do here, I will, before this step, I will replace the second with the third. Why? Because if I have minus here, I have to take the opposite of 34 over 45. So I will rewrite it 17 over 5. I will take this plus logarithm base 2 of 4 over 9 minus logarithm 34 over 45. Now, in this step, I will take the same log, the same base, and now between 17 over 5 and 4 over 9, what? There is what? There is plus. So I will transform it to what? To multiply. So 17 over 5 multiply or times, there is a plus here, transform to multiplied or times, and the second 4 over 9. Now between 4 over 9 and 34 over 45, there is minus. So I will transform minus to divided. Now I will take the same number 34 over 45. This is the first step I did. I transformed plus to times minus to divided. After that, I will transform divided to multiplied and take the opposite of this. So it will be log 2 17 over 5 multiplied by 4 over 9 transform divided to multiplied 45 over 34. Now I will simplify it. How can I simplify it? For 17 there is 1, here there is 2. Okay. 1 9 9 9 1 2. So the results 1 time 2 2 time 1 2 1 time 1 1 times 1 1. So the result will be log 2 base 2 of 2 of 2. And I had a property said that if the base equal to the number, that means it's equal to 1 and it's equal to right hand side. So I prove that this equation equal to 1. I will give you as a homework, sorry, I will write it in another column. Log base 3 of 36 plus find plus log base 3 of 3 over 4. Okay, it's not difficult, you will solve it very easily. Thank you very much guys, see you in the next lesson inshallah.